All right, another way to visualize our data is using a box plot. So let's say we got a data set here of X and Y data, but really all we want to see is the kind of spread that's happening with this. We can visualize it with a box plot. So we'll take this data set, specifically the Y data set, and we're going to call that into Jupyter. And so we're going to try to plot it. So we're going to use matplotlib, which is the main library we're going to use for most of the visualization of our data. And here's our data set. So we called it in and created a library here or a list. And so this is the thing that we're going to work on. So what we'd like to do then is we're going to create a box plot. So we're using PLT because we've defined matplotlib pyplot as PLT. So PLT, and we'd like to make a box plot. So we'll do that, and we want to do it on the variable y. So whatever we've assigned the variable y to, whatever column of data we've got here, y will be acted on with box plot. And so whatever we've got here, if we can make y or whatever variable, we can call it data, and we can assign this to a specific group by data frame if we wanted to as well, and the box plot will be done with that. So this is just a basic version of it, but just to give you the overview, this is the variable. We're going to assign some data to it, and then we're going to pass it through the function box plot, and that's essentially what we want to do. So right now we've created the box plot. I just want to put a label on the y-axis, so I can put a label here like this, and I can call it y that, and then we need to show it. So right now it doesn't do anything until we actually pass the function show. So if we do it all right, hopefully it'll work, and we'll see that we get our basic box plot. So there's our label here. This is the number one. This is the first column essentially. It's not the index because our index is actually started 0, so I'm not sure what the number one comes from, maybe our first data set. But here's our box plot, and so as it's defined, this little yellow line here essentially is our median. This first line up top here will be the 25% above, 25% below. So this box right here represents 50% of the data. This is where the middle line is. Half of the data will be here, half of the data will be here. From this line, 25% of the data is here, 25% of the data is here. And then further, from up to this line here, this is 75% of the data is represented here and 75% of the data is represented here, I believe so. But if we were to look at quartiles, we'll see that this is called the min. This little whisker at the bottom is the min. This is our 25% value. This is the 50% value. This is the 75% value, and this is the max. So these are outliers outside of the actual data frame or data set that we've created. But this is essentially the idea of the box plot. So it gives us a visualization of what's going on, and we can see that if the data is skewed or not. So we can see the whisker here is really close to this bottom data set and up here. And so what could help us here, because this data is kind of skewed a little bit weird, we could actually try a violin plot on this as well. And what that does, it kind of gives us a better idea of the spread of the data. So it kind of goes wide depending on where we might see a majority of the data, and that can help us. But we're not there yet. We're just we're just doing this. So this is great if we've just got a small set of data and you want to type it in here, which is actually kind of laborious in itself. But we want to work on a data set. So let's say, for example, we've got our data set here and we want to work on the box plot for this specific data set right there. We want to do a box plot for this. Well, we would need to read in this data set. We need to assign this data and group it based on group A, and then this can be assigned to a variable, and then that variable can be passed through a box plot function of some sort. So like this, and that's it. That will treat our data. So that's kind of the general idea that we're looking to do. So I've got some information here already, but just note that there are some slight differences. Oops, already gone to it, because the data sets get bigger and bigger, so they need to be a little more complicated as we go along. So I've called this one box plot of one column, and essentially we're going to import pandas because we now need to manipulate the data. We've got a large set of data. We're going to use pandas to help manipulate that, and then we're still going to plot matplotlib. So essentially we need to call in our data set. So we've got one called box plot. And once we call that data in, We can define the columns. Now this one is just to try to see what our columns are, and we can define what we might want to plot. I already know that I want to plot this title right here. So P1 ASA1, this is the one that I would like to see, and I want to create a box plot. So this is similar to what we used before. So if we go over to the basic one here, this is similar here. I've got the PLT as matplotlib. I'm using box plot. But this is a little bit different. I'm creating the data first, I'm manipulating the data first, and once I've got the data manipulated to what I want, now I'm going to pull out the very specific column out of the data frame, and I'm going to plot that. And so instead of saying box plot, we're going to say just plot, it's generic, and we're going to say what kind. And when we did the scatter plot, we could have done the same. We can call it scatter plot, or we can say plot kind equals scatter, and it still achieves the same value, same outcome, and it's all still within this matplotlib library, right? So there's various ways of doing it, and if you're using AI like I do to help you define the code, each time you do it, it can turn out different, right? So, but just note that the outcome is the same essentially, and there's multiple ways to code it to get what you're looking for. Um, this here, so I'm defining columns here, but this, what it does essentially is it will, if there's a string associated with the column, it will strip, this specifically strips any empty spaces at the front or at the end of the column name. And what I found was when I ran this the first time was some of these data sets have right after here, there actually is a space on some of these. So one or two of these actually have a space, and it was difficult to actually get the box plot to go. It wouldn't do it. So what I had to do then was using AI say, this is a problem I'm having, what's going on? And it came in and told me, well, add this to your data set. So once you've defined your columns in a data frame, apply this here and get rid of any of the leading empty spaces, and you should be fine. And sure enough, it worked. So now that my columns have been functionally arranged and I was able to remove all the leading spaces or end spaces in the column names, now I can take a look at the column name that I want. And I chose this very first one here. So this is plate 1 for pure ASA. So we're going to run TLC, and this is thin layer chromatography data over the course of from 2017 all the way until 2023. And so taking this data set here, the entire data set, we're going to create a box plot of that. And so note again, I did not need to get rid of the null values for this calculation. It ignored the null values and was able to do the calculation without them. So again, sometimes it can work depending on the function that you're using, and sometimes it can't work. In the end, we created the box plot specifically for that column. I can change this column name to whatever one of these ones that I want. So any one of these whatsoever, and I can plot it in a figure. And again, there I go. I've got a median. I've got my minimum, my 25%, 50%, 75, and my 100%. And these are all the outliers that are outside this calculated data set that we've got. So pretty straightforward. But what we would like to do is we want to compare more than one column. So this is the thin layer chromatography result for pure ASA. This is a finished product. This is the uh, this is the TLC data for the salicylic acid. This is the starting material. So we know what the pure starting material looks like. We know what the finished material looks like. And this is what we produced. So we call it crude. And it actually has two spots. One spot, the lower spot, actually corresponds to the product that we want right here. This upper spot is starting material. So this is an impurity now because we want 100% this, but as you'll see, we're not getting it. And the second spot here corresponds to that. So we do chromatography, it's able to split up the chemicals into two separate spots, and we're able to visualize that using a TLC plate. We collect the data, and now we run a box plot to see and compare the data. So I want to compare 4 columns worth of data. So we can go here to box plot average columns, but note here that I've got 2 different plates. So this was one plate that was run. So literally a TLC plate, I spotted pure ASA, I spotted pure salicylic, I spotted my crude, one spot for this. It got separated into 2. So this is plate 1, but I did a second plate to be redundant, and so this is the data from that. What I'd like to do is actually average the two plates before we do the box plot. So I want to average these two data sets, these two columns. I want to average these two columns. I want to average these two columns. I want to average these two columns. Sorry, yeah, these two columns like that. And then apply the average to either the year or to the lab day or any of that type of stuff I'd like to do. All right, so that's kind of what we would want to do. So I'm going to then take a look here, and I want to take the box plot of the average columns. So similar before, we're going to call in pandas because we're going to call in data frames to be able to work on the data. This is the matplotlib to visualize the data. We're going to create a data frame from the box plot CSV. We're going to strip the columns again to get rid of those leading spaces that I found in there that were having a problem with me. And now we're going to create essentially new columns. So you can think of them as variables, but really we're creating new columns on the data set. So we've got these two, PSA1 and P2AS. This is from plate, sorry, this one, P1ASA and P2ASA. We need to average these two. They're from two different plates. And so what we're going to do then is we're going to create a new column called average of the plot of or the plate of ASA, and that contains the data from PSA1 and PSA2 or P2ASA and P1ASA. And we're going to get the average, so the mean of those. And the axis minus one or axis equals ones means essentially we're putting it into a new column. So this is now a new column of data. So we don't see it here, but if we wanted to, we could actually plot that. We could actually ask it to print out all the new columns after here, and we would actually see these new columns being added in. So we're creating 4 new columns, 1, 2, 3, 4, based on the averages of the columns that we were interested in. So now that we've got these new essentially variables, these new columns, now we can pass them through the box plot. So here we're going to create a figure. So this just determines the size, but we're going to create a plot of the columns. So we're going to call it subplot, and essentially right there, this is this is it right here. I want to create a box plot. So using this variable data, using this column of data dot, I want to use plot and I want to create a box plot. So that's it for this PSA average one right there. And I can do it for the second one right here, and I can do it for the third one right here, and do it for the fourth one, and so on. And then this says tight layout. I actually don't know what this means, and I would have to go to Copilot, ChatGPT to ask what that is. I could Google it as well, but I find that this is where AI really shines. And then we show it. And here we got 4 box plots essentially of them sort of together. But this is great. And so we've got essentially 4 data sets like this, but I would like to see these essentially side by side if I could, or have them all on the same plot possibly. And let's see if we can do that. All right, so without any formality, here's what we would like to do then. The same plots I had before, like this, same data, same everything, except I want them all on the same graph. So this looks nice, but eventually if I had a series of more, that it would actually start to be problematic. So I want them on the same graph, and so we go through the same exercise, import pandas as PD matplotlib. We read our data into a data frame. We strip out the spaces from the beginning and the end, and we create those 4 averages again. So note that they changed the average title again on us because that's AI what it does. But either way, it's the same effect. I'm creating 4 new columns here, just like I did before, with really long names. I should change the names of these, but this is it. And then so now that I've got these 1, 2, 3, 4 new columns of data, and I've got the means of those data, now I can create a single graph that contains the box plots of each of those 4 new columns. So it's creating a figure size here. This is just the size of the figure. And then it's saying that I want to apply to each of these here individually. What we did before was to each individual one. Let's see here. We created its own box plot. So to the individual data here, create a box plot. To this individual data here, create a box plot. To this individual data here, create a box plot. So note that there's a box plot being applied to each one of those. What's different here is we're putting it all on the same row. So to this entire set of columns, apply a box plot. And what that does then is it puts it all together within the same thing. No different columns for no different plots for everything. It's all in the same one. So we're still applying our data set to box plot, the plot here, but we're doing all of the columns that were of interest. So we could have done different columns, we could have done all sorts of separate columns within a gigantic data set and actually see your box plot. So it's a really nice way of filtering data and figuring out what you want. And way easier to do it than in Excel. Trust me with this one. So this is really nice. So this is the main way that we'll probably go about doing our box plots because we will be comparing um, pure ASA to pure salicylic. And then this will be the crude spots. We'll have a lower spot and an upper spot of the crude. We can't visualize these two on top of each other, but they're treated as two separate columns of data. But in reality, we would have a TLC plate and there would be two spots, one on top of each other. And this is just the data obtained, treating them as two different separate columns. And so that's it. And so we use this comparison then in our lab 3/4 data set to figure out what's going on. So this is just an example of that. So one thing I mentioned before with one of the other box plots was that this skewing of the mean here, sorry, of the median, it kind of means something, and it's harder to visualize. And there's something called a violin plot that actually will take this same data set but express it like a curve. So almost like it's a distribution out this way and a symmetric one out this way. But it kind of gives you where these sort of bulbous areas are. It gives you an idea where the main parts of the data set are. And so a combination of these two are very powerful bits of information. And it's also possible to plot this box plot on a violin plot. Now, for what we're doing, it's a little complicated and we probably won't do it. We'll just do a basic violin plot that shows you where the median is and you can see the skew of the data. And combined with the box plot, we can provide some sort of information out of that, but we won't go further than that.